DC generator. This is a windmill. It is used to convert wind energy into electrical energy. The device used for this purpose is a generator. A DC generator differs from an AC generator, as DC generator produces direct current, and an AC generator produces alternating current. Now let us see the DC generator in detail. Here we can see the schematic picture of the DC generator. The field magnet produces a magnetic field, where the armature is kept. The two ends of the coil are connected to the split ring commutator. Each end of the coil is connected to one half of the commutator, to which the brushes are attached. The external circuit is connected through the brushes. A shaft is connected to this assembly. Initially, the coil is in the vertical position, that is 0 degrees. So there is no change in flux, and hence, no current flows in the coil, as we can see in this graph. By the mechanical force, the shaft starts rotating, say in the clockwise direction. So the armature coil also starts rotating. Hence, there is a change in flux and the current is induced in the coil. By Fleming's right-hand rule, we can find the direction of current in the arm CD. The thumb coincides with the direction of motion, that is, upwards. The index finger shows the direction of the magnetic field. So the second finger shows us the direction of current, that is from C to D. Next, we apply the rule to the arm AB. But we can see that the direction shown by the thumb does not coincide with the direction of the motion. We adjust our hand so that the directions coincide. Now the thumb gives the direction of the motion. The first finger shows the direction of the magnetic field. Hence the second gives the direction of current from A to B. So the current flows from arm AB to arm CD. As the coil reaches the horizontal position, that is 90 degrees, the rate of change of flux is maximum. Hence, EMF induced is also maximum, and also the current as seen in this graph. The current enters in the external circuit through B2 and leaves the circuit at B1. During this position, arm AB faces the North Pole, and arm CD faces the South Pole. Here, brush B1 is in contact with S1 and brush B2 is in contact with S2. But as the coil rotates, it reaches the vertical position that is 180 degrees. There is no change in flux, and hence, the induced EMF is 0. Again, due to the coil's rotation, the current starts flowing and the coil reaches the horizontal position. That is 270 degrees. Initially, the arm AB was facing the North Pole, but now it faces the South Pole. And also the arm CD, which was initially facing the South Pole, now faces the North Pole. Now AB experiences an upward force. So Fleming's right-hand rule shows that current flows from B to A. Similarly, for arm CD, the current flows from D to C. Now the current flows from segment CD to segment AB. But the position of split rings is reversed. Brush B2 is in contact with S1, and B1 is in contact with S2. So the current again enters the external circuit at B2 and leaves at B1. Hence, the direction of current remains the same in the external circuit. Again, by rotation, the coil reaches the vertical position that is 360 degrees, and the current induced is 0, as we can see from this graph. But the rotation of the coil continues, and hence in this way the direct current is produced from the DC generator.